Hello everybody, welcome back to another discussion dynamics. Today we will continue kinematics of particles. As you can see, here we are on our timeline. Okay, and topic we will cover today is following. It's kinetics in normal tangential coordinate system. And the only difference between today's discussion and the discussion you've seen last time is that last time our particle was following a straight line. Yes, the trajectory was a straight line. Today the trajectory will be curved. So today we will just do exactly the same, but in a curvilinear sense. And we will solve example number 1 and example number 2. No lecture review today because I will just cover lecture review while solving the problems. Okay. Without further ado, example number 1. As usually, please read and understand the problem statement before we start our solution. Okay, so what do we have in here? We have our car that has mass m, right? And that car is traveling with constant velocity, vc. And they ask us to consider the motion of that car at 3 different positions. Yes, position A, position B, and position C. What's the difference between them? The curvature, yeah, the curvature they are following. The car is experiencing at these 3 points. So in here, car is on top of the hill. In here, car is like at the bottom of the valley, I would say. And in here, our car follows a straight line. Yes, the trajectory is a straight line. And they ask us to find the deceleration of that car at these 3 points, knowing that this is coefficient of friction between the ground and the car. Okay, this is the problem statement. Let's write down what we know and what we don't know. Knowns. I think that we know mass of the car. I think we also know coefficient of friction. I think we also know radius of the curvature. And I think we know that velocity of the car is constant. Okay, and they ask us to find deceleration, yes? So basically they ask us to find AT, so the tangential component of acceleration. AT at positions A, B, and C. I hope that the problem statement is clear, right? So let's solve. Let's solve maybe for part A. Yeah, solve. Solution case A. So this case. So we are just going to follow that solution steps I gave you last time, okay? So first of all, we'll start with FBD and KD for our car, okay? So I will represent that car with this rectangle here and here. What forces act on our particle? I think it's mg. I think that there is a normal force, right, acting on that car. And watch out for spoiler alert, that n will be smaller than mg. At this configuration, n will not be equal to mg, n will be smaller than mg. Let's see, we will see if that's true or not, okay, at the end. And there is one more force acting on the system. I think it's friction, right? So since velocity is pointing to the left, I think that friction will point right. That's it, right? There's no more forces. Okay. And now KD. So this is the first difference and probably the only difference between what happened last time and today. So this is our trajectory, yes? Let me put trajectory, yeah? So our car follows this circle, right? This is our trajectory. It's clearly a curved linear motion, right? So I decided to express this motion in anti-coordinate system. Okay? So that means that our un will be pointing inside the circle, and our ut will be aligned with the velocity, right? And since our velocity is pointing to the left, our ut will be also pointing to the left. Okay, so now let's introduce our accelerations there. So this is our MAN, and this will be our MAT. Okay, I am done with FBD and KD. Have I lost you anywhere? Any questions? Okay, so that's how it's done, yeah? So now once we have FBD and KD, now let's write corresponding equations of motion that our particle has to obey. Equations of motion. So I'm gonna sum the forces along the t direction, where I specify that this direction is positive, and also I'm going to do the same in the n direction, where this direction is positive, right? So what do we have in the t direction? Only one force, and it acts in a negative direction, t minus tf, and this will be equal to mat. And in the n direction, we have two forces. We have mg minus n, and this is equal to man. Yeah, that was not that bad. So now there is one extra thing we didn't do last time, actually. So this is so when it comes to curved linear motion, I would like you to recall that these are the expressions for the acceleration components. I hope you remember them. So A has dv dt times ut plus v squared over rho un, right? And by the way, these are exactly definitions for at and an. These are expressions for our acceleration components enforced by the curvature it follows, okay? So basically what I'm gonna do, I'm gonna replace them. I'm gonna replace at and an with these values. So in here I will just write dv dt. Usually I will do it. And in here I will write v squared over rho. Yeah, but our rho is r. It's constant. Yeah, it's constant radius. So usually I will do that. I will do that replacement. Okay. However, in this problem, they just ask us for at. They ask us to find at. Okay. So let's keep it there. Okay. Let's leave at in there. Okay, guys. So let's see what we have in here. We have these two equations. And let's see what we can do with them. I believe that we can take second equation and we can find normal force, right? Normal force is equal to mg minus m v squared over r. Seems like I was not lying to you, right? Normal force is indeed smaller than mg, yeah? And this is due to the centrifugal force, yes? Our car is experiencing at the top of the hill, yes? That centrifugal force is pushing our car upwards, yes? That's why our car does not press that much on the ground. You see that? Cool. Okay, and let's look at the first equation, yeah, because they ask us to find at, and we have friction there, yeah. We should probably go for some friction law, yeah. So I think that in here we have kinetic friction. So this will be Tf equal to mu k n. Okay. So, and we know n. Yeah. So this will be mu k times m g minus v squared r, close the bracket. Okay. So I'm just going to plug this value right here. And we will end up with following thing. MAT is equal to minus mu k m g minus v squared r. I think m's cancel out, and we ended up with such expression. And well, that's the end of the problem, yeah? This is what they ask us for, yeah? Find AT. Okay, so this is our answer. This is answer A. That's it. Any questions? And it is clearly a deceleration, right? Because you can see that there is a minus here, yeah? Our car slows down, yeah? Olivia? Yes. It's not zero, yeah. But so you asked me two questions actually. Yes, we're looking only for AT because why? Because they ask us for. You know, do you mind if I scroll up the board? I'll just scroll up here. Look, they ask us to find instantaneous deceleration. Yes, by saying that they mean find AT. Yeah. So this is my answer to your question. That's why we find AT, because they ask us for. This is what the problem is about. Yeah. And now second part of your question is why we don't find AN, and if it's zero. We actually found it. It's here. So your AN, can I put it here? AN is velocity of the car divided by R. Yeah. We know velocity of the car, and we know the radius. So we actually know that value. Yeah, this is the acceleration, yeah, and it's not zero, yeah. It would be zero on the if it's a straight line. In case B, this will be zero. Okay, but not when we follow the curved path.
It would be negative though, right? Yeah, because we're going up, trying to hit the jump.
It would be pointing towards the center of the circle. No, I'm kidding. Yeah, no. Yes, yeah, because it's AN. N always points inside the circle. Yes. Okay. Are we good? Okay, guys. So this is our answer A. So that was obtained for this case, right? When our car was at the top of the hill. Okay. So this is our case A. So now maybe instead of tediously solving part B and part C, maybe you can just have a look at our answer and maybe you can figure out what will the answer be for B and C, okay? So this is case B, and this is case C. Okay, guys, so can you please tell me, just by looking at this answer we just obtained, can you please tell me what will be AT for case B? I can give you even a hint. What is the radius of this curvature? You are on the wrong side of the spectrum, sir. What is the radius of straight line? It's infinity. Yes, it's infinity. So that means that I probably can copy this here, right? But instead of that R, I can put there infinity, right? And by infinity, I of course mean very, 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 very large number. Yes? So that means that if I divide by a very, very large number, that means I can actually get rid of that. This would be 0. Yes? So this will disappear, this component. Okay, so I will erase it. Are you fine with that? Just erase it. Yeah. And this is the answer. That's what's left. This is the answer for case B. Okay, how about case C? Yeah, exactly. This is what I was getting at. Yes. So basically, could you please tell me what is the radius at point C? Yes. However, let's assume that radius in case A was R. So if RA is R, what would be RC?
R.
Negative. But negative, yeah? Negative R. Yeah. So basically what I have to do, I just have to copy this. Paste it here and probably just flip that sign. Just instead of minus, I should have plus in here. That's it. We solved the entire problem. Yeah. I actually have nothing else to say, guys. So, James?
When it comes to like quizzes and exams, would you still probably want to work through each and every point, or can you like explain that you're using logic from like a previous part to get the other answers?
I do not like these types of questions, yes? So this is my answer. We are not here to torture you, yes? But I usually do not like answering such questions, yes? So basically, when you provide solution to the exam or quiz, you must convince the grader that you understand the problem. Okay? This is my answer to your question, yeah? Please don't ask. This is the second time you asked me the same similar question this semester. It was you, I believe, yes? You asked me the same question like a couple of weeks ago. I believe so. I might be wrong, but I think it was you. Please don't ask these questions to me. My answer for such questions is convince me that you understand dynamics. Okay? Are you happy with my answer? Because I don't know what to answer. Like, also, if you do not believe me that this is true, that this is the correct values, yeah, you can at home solve that problem one more time, following the steps I just showed you. Yeah, so you can at home you can just draw a free body diagram, write down equations of motion, solve them, and you will. I promise you will obtain these answers. Okay. So by the way, before moving to example number 2, could you please tell me which deceleration is the largest? When the deceleration will be the largest? In which case? A, B, or C? Exactly, yeah. And do you see why? Because the normal force acting on the car will be the highest, yeah? Because our car is in that valley, yeah? So it will be pushed towards the ground, yes? And that's why the friction will be the highest there, and that's why the deceleration will be the largest. Okay, so yeah, in case C, the deceleration is higher, the largest. Yeah. By the way, in here, normal force will be larger than mg. In this case, normal force will be exactly equal to mg, and in here, normal force will be smaller than mg, as you could see, yeah, earlier. Yeah. So just a digression. And this is all because of the centrifugal force. I don't see any questions. So what? Do you want to do example number 2? Okay, let's do it. So as usually, take a couple of seconds to read and understand the problem statement. Okay, guys, so what do we have in here? Now we have racing car, yes, and we again gonna model it as a particle, yeah, and our racing car is moving on the racing track, yeah, on the speed track, yeah, and that speed track has radius, I believe, of 200, right? So this is the radius of the speed track, 200 meters. Okay, and I think that I can even, maybe just to make things even clearer, do you mind if I just draw that racing track very quickly? Because with that information, you will all see that our car actually moves on the conical surface, okay? So this is the racing track. I hope I can draw it. Something like that. Something like that, I believe. Okay, so this is our racing track. And our car actually follows this trajectory. Okay? So this is our trajectory. Okay, and this is the theta angle. Okay, my point here is to show you guys that our trajectory is a circle, right? So our car does not slide. It does not slide up or down. Okay, it just stays at that circle. Okay, it cannot leave that horizontal plane. Is that clear? Yeah. So our car cannot leave this horizontal plane. It has to stay on this plane. And that circle has, of course, radius r. Okay, so what do we know? We know that our radius is 200. We also know that our V rated, or VR, just to save some ink, okay? VR will be 180 kilometers per hour. Let's bring it to meters per second, okay? Because this is more physical value. So if I want to do it, I will have to multiply it by 1000, I believe, and I have to divide it by 3600 seconds, right? If I do that, I will end up with 50 meters per second. And also, they told us that there is something like velocity skidding. So it would be Vs, just to save some ink. And this is equal to 320 kilometers per hour. And if you want to bring it into meters per second, you will end up with 88.889 meters per second. Okay. And they asked us to find three things: banking angle theta, coefficient of friction between track and our car, and also minimum speed to prevent the sliding down. Let's do it in a wild way, okay? Let's start from beginning, okay? Let's start from part A, okay? So this is my solution A. And believe me or not, solution A can be, part A can be solved when we consider the car traveling with velocity rated. Our car has to have speed V rated in order to solve part A. Before we start solving the problem, what is specific about that velocity? Yeah, can any of you tell me how this velocity will impact our solution?
Does it mean that there's no friction like on each side of the car?
Perfect. Yes. Yeah. I thank you for that answer. Yeah. Even if you were like silent for a little bit longer, I will give you a hint. Yeah. And the hint would be following: how that case would impact our free body diagram. Yes. Exactly. There will be no friction. Yeah. Let me tell you what we are talking about. Okay. So in solution A, we will just draw a free body diagram because we follow my recipe, right? FBD, but it will be for velocity v rated, okay? And let's not forget about the twin brother of FBD. Let's not forget about KD. Let's model our particle as a rectangle again, okay? I think I can make it smaller. Yeah. So I'm going to model that car as a rectangle. So rectangle here and rectangle here. And Jason said, it's Jason, yes? Jaden, I'm sorry. Jaden said that there is no friction because he read this part, yes? And he also not only read, he read and understood it. Exactly, yeah. So let me put some forces here, yes? So we'll have mg in here and also normal force in here. And Jaden said that there is no friction, so these are only two forces acting on our system. Okay. And now let's, so this is a curvilinear motion, right? Because our body goes around the circle, yes? So I again decided to go for anti-coordinate system. Okay? And our circle is there, so that means probably that our UN will be pointing this way. I hope you can all see that, yeah? And also I believe that the velocity of that car is pointing out of the board, yeah? It's pointing towards you. So this is our UT. And let's also introduce here Z direction, okay? So K. With that coordinate system specified, I think that we can draw here MAN. We can draw here MAT, and we can also draw here MAZ. Okay. I think we're good. We have all the forces, and we specified the inertia forces as well. So let's write down equations of motion. Unless there are questions. You with me, guys? Everything is clear? Cool. So let's do sum of forces in these three directions. In T direction, in N direction, and in Z direction. What are the positive directions here? I believe that T direction will be pointing this way, N direction will be pointing this way, and Z direction will be pointing this way. Okay, what is happening in the T direction? Nothing, yeah? Zero, no forces. So zero here. And this is equal to MAT. So clearly you guys can see that our AT has to be zero, yes? So that implies that our velocity is constant. Yep. Is there anything interesting happening in the N direction? Yes, I believe so, yeah. And I have to project N on that direction, right? So I have to come up with this component of N and this component of N. Okay, but before doing that, I must bring this theta somewhere there, yes? So if theta is here, I believe that theta will be here. And also here. Okay, so with that theta, for that case, I think that this will be N sine theta, and this guy will be N cosine theta. Nice. So this is N sine theta, pointing this way, and this is equal to M AN, and in the Z direction, I will have N cosine theta minus mg, and this is equal to M A Z. Okay, let me maybe like organize it a little bit. I like when the equality signs are aligned, you know. It looks like nicer to our eyes, yeah? Okay, guys. So in the curved linear motion, we specify an as v squared over rho, right? Yeah. So basically, this will be v squared over, and it's not like any v, yeah? We are solving that problem for v rated, yes? So it will be vr. Let's put here subscript r, yes? And also we will divide it by rho, but our rho is constant, yes? Our rho is equal to radius of that track, yeah? Okay, so basically this is that. And maybe you can tell me also something about z. I think that we know value of z. Can you guys tell me what z is? If you look at that trajectory even. Our car follows that circle. Can it leave that plane? Yeah. So you all know the answer. Yeah. Az will be 0. There's no motion outside of that plane. Cool. So let's recap. Let's recap what we have. We have these two expressions. This will be equal to m v rated square over r, and this is 0. Okay, so we have two equations. They ask us to find theta, I believe, yeah? They ask us to find that banking angle. And is there anything we don't know else? Normal force. And I believe that we know everything else. Okay, so we have two equations and two unknowns. Let's solve it. So I think that from the second equation, we will know that our n is equal to mg cosine theta divided by cosine theta. So as a digression, it's again larger than mg, yeah, because cosine can be at least 1, yes? So n is larger than mg again, and this is again due to that centrifugal force that pushes our car into the track, yeah? Let's plug this value in this equation. So we will end up with mg tan theta, and this is equal to m v rated squared divided by r. We can get rid of these m's, and I think that our theta will be equal to arctan v rated square divided by gr. Okay, let's plug in values. This will be 50 meters per second, 9.81 times 200. Okay, if you grab your calculators, you will obtain that our theta is approximately 51.875 degrees. Answer A. Okay, thank you for help, guys. Yeah, thank you for all of the suggestions. But you can also have questions, maybe. Yeah, are there any questions? What do you think about these discussions? Am I doing like an okay job so far? Yes, it's fine. Cool, thanks for that. Okay, so seriously, no questions? So what, for part B? Do you want to do part B? Okay, let's do part B then. Okay. What was the question there? Let me copy it, okay? Okay, so they ask us to find coefficient of friction between the truck and the car, yes? So we must solve that problem once again, but for a different velocity, yes? Because at that velocity, derated, there was no friction, yes? So right now we must solve that problem once again, but this time car will be traveling with a different speed. Any propositions? What speed it should be? I can even scroll up the board for you. Which one should we go for?
88.9.
Yeah, because there's no other choice, yes? This is the only one they gave us, actually, yeah? So, and this is a skid, yeah? So that means that if our car travels with larger velocity than this one, it will start going which way?
Upward.
Yeah. Do you see, guys? So basically, if you look at the top right corner, yeah, basically for v skid, for this velocity, our car will be will still be at that circle. Yeah, will still be at that red circle, yes? But once our car hits the velocity higher than v skid, it will start moving upwards, yes? Up the incline. Do you see that? And the trajectory will be basically a spiral, kind of, yes? Around the conical surface, yeah? Okay, cool. So this time, we are basically, I'm going to scroll down the board, and we're going to solve exactly the same problem. This time, for velocity equals to velocity skid. Okay. And KD in here. So I can actually copy paste my FBD, but I never liked when my instructors were doing that, yes, because they were always like ahead of me. So let me draw it quickly with you, okay? So this is that rectangle, this is that rectangle. What forces were there? mg here, normal force there. I believe that we are going to express our motion in exactly the same coordinate system. So we will have MAN pointing this way, we will have MAT pointing this way, and MAZ pointing this way. Yeah. And the only difference between this case and the previous one is that friction force, right? So definitely our friction force will be along this direction, and it will be pointing up or down. Down, yes. Ben, is your name Ben? John? Sorry. Yeah. So our TF will be pointing this way. Exactly. So let me also put this mg here. Okay, so what now? Now equations of motion, yeah? EOM. So we have sum of forces in the t direction, in the n, and in the z direction. Okay, again, no forces in the t direction. 0 is equal to MAT. How about n direction? Okay, projections again. I think I remember correct that was n sine theta, and that was n cosine theta, because theta was here. Okay, but I have to now project TF, right? So if theta is here, I will have these two projections. So this green one and this green one. So if theta is here, I believe that theta is here as well. So does it mean that theta will be here? I believe so. Okay, so that will be TF cosine theta, and this vertical one will be TF sine theta. Okay, we are ready to write down our equations of motion. So in the n direction, we have n sine theta plus TF cosine theta. And this is equal to MAN. And in the z direction, we have n cosine theta minus TF sine theta minus mg. And this is equal to MAZ in general. Okay. So now, again, we will set AZ to 0 for the same reason as before. Our car cannot leave that horizontal plane, okay? And AN will be, again, V squared over R. But this time, it's not going to be V rated, yeah? This time, it's going to be V skid, yeah? So let's put subscript S in here. Okay, guys, so we have these two equations. And we have this guy equal to mv skid squared over r, and this is 0. So far, so good? Yeah. I think that they ask us to find coefficient of friction, yeah? So let's introduce that coefficient into our equations, yes? And of course, we will introduce it via some friction law, yeah? So we have static friction. It's static because our car does not move up and down, yes? Our car does not move neither this direction nor this direction, yes? So it has to be static, yep? But it will be a very specific case of that static friction. It will be maximum static. That's why our TF will be equal to mu s n. And that equality sign in here is only because this is maximum static friction, okay? So now I hope you don't mind if I just rewrite the same two equations, but this time I will just plug TF, the expression for TF in here. Okay, can I do that? So I'm just gonna copy these two guys. I'm gonna copy them here, but instead of TF, I'm just going to write mu s n and mu s n. Okay, so we definitely have two equations, and how many unknowns? For sure, we don't know coefficient of friction, and we don't know n. And it looks like we know everything else. So that's great. I mean, that's great because we can solve it, right? So we have two equations. Yeah. Cool. So you can use your mathematics skills to solve it. I did it yesterday, and here is the answer I obtained. Okay. So if you want to find mu s, this is what you should obtain. Mu s is equal to exactly Vs squared cosine theta minus gr sine theta divided by Vs squared sine theta plus gr cosine theta. This is the expression I obtained yesterday. And now I just have to plug in values and grab my calculator and find it. Yeah. So values are following. Vs is equal to a lot of 8s, meter per second. Theta we found in the previous step. It was, I believe, 51.87.5. Yeah, that was the value of theta we found in part A. G, you know what is G? 9.81 meters per second square. And R was 200. Okay, let's plug in these four guys here. And if you do it, if you grab your calculator, you will obtain that mu s is approximately 0.449. answer B. Okay, guys, any questions so far? We have 2 more minutes. Okay, so let's do quickly part C. Okay, let's do part C quickly. This is the question. So I hope you can all see that there is like a dependency on what our car is doing and the velocity it has, yeah? So if the velocity is too high, our car will start skidding, yeah? If the velocity is too high, our car is gonna go this way, yes? It's gonna create such spiral, yes? But if the velocity is too small, it will just start sliding down, yes? So it will create smaller and smaller spirals, yes? Do you see that? So basically in this part, they ask us to find that minimum velocity before it starts going this way. Do you see that? Okay, so let's solve it in 60 seconds. Let's do it. So I'm gonna draw free body diagrams and so on. No, I'm not. I'm just gonna copy them from earlier, yes? And you will tell me what I should do to them. So this is my free body diagram. Oh, it doesn't listen to me. Wait a second. Here it is. It's getting closer. Yeah, it's here. Okay, guys. So there's only one difference I should do to my free body diagram comparing to the one we already draw. What is it? Exactly. I should flip the direction of the friction. Yeah? So in this case, TF will be not pointing down the incline, but it will be pointing up the incline. Yes, and all the solution steps are exactly the same. And if this is true, I think that I can also copy the equation of motion, right? I can copy the equation of motion. And since we just flipped TF, our equations of motion will look like that. I just have to flip this sign and this sign. It was before plus, so now it will be minus. And this one was before minus, so now it will be plus. Yes? Yeah. Okay, and they ask us to find velocity mean. Yeah, so instead of VS, I will put mean in here. Okay, guys. So if you want to solve this for V mean, this is what you would obtain. Just follow the same steps we did in part B. V mean will be square root of something. It will be square root of GR sine theta minus mu s cosine theta plus mu s sine theta. If you plug in values, you will obtain that V mean is approximately 32.091 meters per second. This is the end of discussion. Thank you for today and hope to see you next time. Bye.